Hey, what's going on guys, Turty here, and welcome back to another Minecraft modding tutorial for version 1.15. In this tutorial I'm going to be covering how we can go ahead and create our custom furnace. Now this has been, might I say, a long awaited tutorial, and I do apologise for the delay. I've just been trying to make it as efficient and best code as I can. It's probably still not going to be perfect, of course. But yeah, so obviously for the first thing we need to go ahead and do is create our block class. Now obviously this needs to extend block and just have the default constructor, and then we need to go ahead and create two properties for this. This will be the facing property and the lit property. So for the facing property, that will be a public static final direction property. I'm just going to call that facing, and that can just be equal to block state properties.horizontal facing. And then we can create a public static final boolean property, and we'll call that lit, and that will be equal to boolean property.create. Just take in the name, which I'm just going to put lit. Then we obviously need to set the default state in the constructor, and we can just do that by calling this.setDefaultState. That takes in this.stateContainer.getBaseState. And then after that we can do .with. That first takes in the property, so the first one will be facing, and then the value we want the default to be direction.north. Make sure you import the direction from net.minecraft.util.direction, not from the chunk palette thing. And then we need another .with. This takes in lit, and for the value it will just be false. Then we obviously need to override the hasTileEntity method, make sure it is the one with the block state, and in here we can just return true. Then we obviously need the createTileEntity method, in which we will return modTileEntityTypes.exampleFurnace.get.create. Then we need to make sure we override the method fillStateContainer so that we can actually add these properties to the block. And in here we first need to call the super, and then we need to add the other ones to the builder. Then we just need to override the mirror method, in which we will call state.rotate, and that will take in mirror.toRotation, and that takes in the facing. Then we need the rotate method. For that we can just go ahead and copy this mirror method, rename it to rotate, and change mirror to rotation. And we can change state.rotate to state.with, and then put in the facing, and then instead of mirror in.toRotate we just want to put rot.rotate. Then, since it is a furnace and the lit state we obviously want to emit a light, we can override the getLightValue method. In here we want to return whether the state is lit, and if it is we just want to call the super, and else we just want to put 0. And if you want you can just suppress this for deprecation. Then we obviously need to override the getStateForPlacement method. In here we can just return this.getDefaultState.with, and that will take in facing, and context.getPlacement horizontal facing .getOpposite, and this just makes sure it places it in the opposite direction to the way you are facing. Next we want to override the method onBlockPlacedBy, in which we will first call the super. Then we will check if the stack has a display name. If it does have a display name, we want to get the tile entity from the pos, and then we need to check if this tile is instance of our tile entity class, which I'm going to call example furnace tile entity. Now if it is, then we want to call tile.setCustomName, and that will take in stack.getDisplayName. And obviously we need to go ahead and cast tile to our tile entity class. Now obviously we are doing this because we want it so if they rename the item in an anvil, it will change the name in the inventory, since that is what vanilla does. If you don't want to do that, you can just completely remove this method and ignore its existence. Next we want to override the method hasComparatorInputOverride, in which we will just return true because we want to be able to handle the comparator input ourselves. And then we obviously want to override a getComparatorInputOverride, In here we will return container.calc redstone, and that will take in the tile entity from the pos. Finally, we need the animate tick method, which will do all of the particles and stuff. I'm not going to go ahead and code that all out because that will take a while. The link for this little block of code will be in the description, and it's just for playing the sounds and spawning the particles. Obviously, if you don't want that, or you want different sounds or something, you can go ahead and change this how you want. This is just the vanilla furnace stuff. Next, we need the onBlock activated method. First, we will check if the world is not null and that the world is not remote. The reason we are doing this is because, of course, we don't want the world to be null, and we don't want it to be client side. So obviously checking that it's not remote will mean that it's server side. If that is true, we can get the tile entity from the pos, and then we can check if that is an instance of our tile entity class. If it is an instance, we want to call networkhooks.openGUI. This will take in the player and then our tile, and you need to make sure you put the pos at the end, otherwise you'll get some strange errors later on. Now obviously this gives us an error because we need to cast the player to server player entity, and we need to cast the tile to inamed container provider. Now that we have done that, we can just return action result type.success, and we also want to return action result type.success at the end. Now one last method we need is the Unreplaced method. Here we first need to check if the state has a tile entity. We also need to check if the state.getBlock is not equal to the new state.getBlock. If both of those are true, we want to call worldin.remove tile entity. Then we want to get the tile entity at the pos. Then we obviously need to check if that is an instance of our tile entity. If it is, we can just create a field for that tile, and then we can create a field for an item entity. And then after that we can call furnace.getinventory.toNonNullList .for each, and in here we can just do item, and let's just rename this up here to item entity, and then we can set item entity to a new item entity, and then we can add that item entity to the world. Now we actually do need to go ahead and move this if statement below this code right here, otherwise the tile entity won't actually be there when we attempt to do that. Now we can go ahead and close this class, and we need to go ahead and initialize the block and the tile entity. And obviously we can just do the normal stuff for that. I'm not going to go over that too much. And then we can just do the tile entity, which will be the same as all our other tile entities. Now obviously we're going to have some errors here because we haven't created our tile entity class, so let's go ahead and do that. Now obviously this class will just extend tile entity, but it needs to go ahead and implement two things. It needs to implement itickable tile entity and also inamed container provider. Okay, now the first thing we want in here is obviously the constructor, and then we want the second constructor. This one will just be a blank constructor where we call this, and that takes in our mod tile entity types, for example furnace. Then we need to go ahead and add the unimplemented methods. Now for the create menu, let's just go ahead and rename some of these. So let's make these all final, and then let's rename them. So this one is the window ID. This one can just be the player inv, and the last one can just be the player in. In here we obviously need to return our container class, and that takes in the window ID, the player inventory, and this. Now we need to create a bunch of name methods to handle the name handling. Now if you don't want it to change the name of the inventory based on the name of the item stack, you can leave all the methods I am about to create and just use this getDisplayName method as the name. First method we need to create is a setter for the custom name, so that will be a public void set custom name. That will take in an iText component, which will be the name, and in here we can just do this.customName is equal name. Now obviously we need to go ahead and create a field for this custom name, so that will just be a private iText component. Then we can create a method to get the name, so that will just be a public iText component get name. In here we will return this.customName is not equal to null. Now if it's not, we can return this.customName, else we can return this.getDefaultName. Then we obviously need to create this getDefaultName method, and that will just be a private iText component getDefaultName. And in here we can just return a normal text component, so that can be a string or a translation or any of the other millions that there are. Now in the getDisplayName method we can just return this.getName. Finally we can create a getter for the custom name, and we can annotate this with nullable. Now let's just go ahead and override the read and write methods. In the write method we just want to return compound, but before that we need to call super.write. Now let's first deal with the custom name. So we can check if the compound contains. So if compound.contains, in here we will take custom name, and this will just take in a value of constant.mbt.tag_string. Then if it is, we will set this.customName to itextComponent.serializer.fromJSON, and that will take in compound.getString, and that will take in custom name. In the write method we first want to check if this.customName is not equal to null. If it's not, we can do compound.putString, and in custom name we will put itextComponent.serializer.toJSON. Now let's go into the tick method and handle what we want to do every tick. So the first thing we're going to do every tick is create a boolean called dirty. Now the reason we are creating this boolean is because we don't want it to mark dirty every tick. We only want it to mark dirty when it needs to mark dirty. And what do I mean by mark dirty? I'm aware some of you may not know. So mark dirty basically tells it to write and read from disk. So it doesn't actually do it, it just tells the game to do it. However, it is quite an expensive operation in actually calling it. So calling it does some expensive stuff afterwards. Obviously reading and writing is quite expensive, and you only want to do that when you need to. So after that we need to go ahead and check that the world is not null and that it is not remote. And the reason we need to go ahead and do that is because obviously we want it to only happen on the server side. We only want server side logic, and then obviously since we are marking dirty, that will go ahead, read write it to disk, and then it will read it, and then the client will also get the info. In here we first are going to check if the block is powered. Now the reason I'm doing this is because eventually I'm going to be changing this furnace so it uses energy, but currently I just want to check if it is powered by redstone. So this furnace is not going to have fuel. Obviously if you want it to have fuel, instead of checking it's powered, you check if it is a fuel item in that slot, and you can just look at the normal furnace code for that if you wish. So to check if it's powered, I'm just going to check if this.world.isBlockPowered, and that takes in this.pos. If that's true, then we will do all the logic here. So we'll first check if the recipe is not null, and we're going to do that by creating a method called getRecipe. So this will be a private method, and it will return our recipe class which we created in the previous video on recipes. So it will be a private example recipe, and we'll call that method getRecipe, and that takes in an item stack. So this will just be the input that we are checking if it is a valid input. So we first obviously need to check if it's null. If it is null, we just want to return null, in which case we just want to go ahead and annotate this with @nullable. If it's not null, we want to create a set of iRecipe, and I'm just going to call this recipes, and that is going to be equal to a method called findRecipesByType. Now this will take in our recipe serializer init, example type, and then it will take in this.world. Now if we needed this recipe on the client side, we would just get rid of this.world, but since we are doing all the logic on the server side, we just need to put in the world so that it has the world. And then we're going to loop through all the I recipes in the recipes, and then we are going to cast that to our recipe, and then we are going to check if recipe.matches, and we're going to check if that matches a new recipe wrapper. That takes in this.inventory, which we obviously haven't created yet, and it will take in this.world. If it does match, we just want to return the recipe. And if it doesn't match, so if it comes out of this for loop and it hasn't returned the recipe, we just want to return null. Now obviously we need to create this find recipes by type method. Now we just need to make sure this is static and that it is public. In here we want to check that the world is not equal to null. Now if it's not, we want to do world.getRecipeManager.getRecipes.stream.filter, and in the predicate we want to check if the recipe type is equal to the inputted recipe type, and then .collect, and that will take in the collectors.toSet. Now if that world does happen to be null, we just want to return collections.emptySet. Now we just want to duplicate this method. This will be the client one, so we can just add the @onlyInDis.client annotation, and we can get rid of the world here, and we can create a client world using minecraft.getInstance.world. Now obviously if you wish, you can just go ahead and suppress that, which I am going to do. Now we are going to create a public static set of item stack, and this is going to be called getAllRecipeInputs, and this will take in an iRecipe type and the world. In here we will first create a set of item stack, and we'll call that the inputs, and that's going to be equal to a new hash set. Then we'll create a set of iRecipe, and we'll call that the recipes, and that will be equal to find recipes by type. That takes in the type and the world. Then we're going to loop through all the recipes in the recipes, and in here we're going to create a non-null list of ingredient, and we'll just call that ingredients, and that is going to be equal to recipe.getIngredients, and then we'll loop through all the ingredients, and in here we'll loop through all the stacks in ingredient.getMatchingStacks, and then we can call inputs.addStack. Finally we can just return inputs. Now let's go back to our tick method, and in here we can do if this.getRecipe, and that will take in this.inventory.getStackInSlot0. The reason we are checking the 0 slot is because that is the input slot, and we just need to check if that's not equal to null. If it's not, we want to check that the current smelt time is not equal to the max smelt time. If it's not equal, we want to increment this current smelt time, and then we can set dirty to true because we have changed a value. Now let's just go ahead and create this current smelt time and this max smelt time, and I'm just going to set that to 100 ticks, but you can set that to however long you want the smelting to take. Obviously you don't have to set it to a constant, you can make it based on your different items, however you want to do that, but I'm just going to do it like that. Now if it is not equal to the max smelt time, then that means it has finished, and then we can set the current smelt time to 0. We can get the output from this.getRecipe, and that will take in this.inventory.getStackInSlot, obviously that will take in 0 because we want to get it from the input slot, and then we will call .getRecipeOutput. Then we can call this.inventory.insertItem. This will take in the count, which is just 1. Then it will take in the output, so we can call output.copy, and then whether we want to actually simulate it, which we don't want to simulate it, we want it to actually happen. Then we can decrease the stack size in the input slot, and then we can set dirty to true. At the end of the tick method we can check if dirty. If it is, we can just call this.markDirty. Now I would guess that you have all noticed by now this inventory variable does not exist, and I'm not crazy, we are going to create it now. Now we are going to be using item handlers for this inventory, since that is the way you are meant to do inventories, but in the past I have been using iInventory, which let's just say is not the best choice of things to do. So I'm going to create a private example item handler. Now in the constructor we want to set that, and we're going to set that to a new example item handler, and that will take in the size of the handler, which will be 2. Now let's just go into the read and write methods, and let's go and read and write some stuff. So first we need to read and write the inventory, and we can do that by creating a non-null list of item stack, and that will be the inventory, and that will be equal to non-null list.withSize. That takes in this.inventory.getSlots, and then itemStack.empty. Then we want to call itemStackHelper.loadAllItems. That takes in compound and inventory. Then we want to do this.inventory.set non-null list, and that takes in the inventory. Finally, we can set the smelt time to compound.getInt, and that takes in the name of the compound, which will just be current smelt time. Now in the write method we can just call itemStackHelper.saveAllItems. This takes in the compound and this.inventory.to non-null list. And then we can do compound.putInt. This takes in the name, which is just the current smelt time, and the value will be this.current smelt time. Next we can create a method to get the inventory, and that will return an iItem handler modifiable. Then we need the synchronization methods, which I'm just going to copy in. You can find these in the description or from my GitHub, whichever one you find easiest. And then we need to override the getCapability method. In here we can just return capability item handler .item handler capability .orEmpty. That'll take in cap and lazy optional.of, and that takes in a supplier of this.inventory. Now obviously we have a load of errors because it doesn't know what the example item handler is. So let's go into our util package and let's go ahead and create this class. This is going to extend item stack handler. In here we first want the constructor, and this takes in an int size and an item stack ... stacks. And then we can just call super of size. And then we want to loop through the stacks.length, and we want to do this.stacks.set. That'll take in the index and then stacks of index. This way we are setting the stacks to an actual stacks that we put in. Then we want a clear method, so that will just be a public void clear. In here we once again want the same for loop. However, instead of it being stacks.length, it will be this.getSlots, and instead of stacks of index, it will be itemStack.empty, and then we want to call this.onContentsChanged. Now for time's sake, I am once again going to ask you to copy these in from the description. Obviously you can type them out if you want, but I'm going to copy in the rest of the methods, as that will save us a lot of time. They're pretty self-explanatory what they do, so I'll just quickly go through them. This one checks if the handler is empty. This one just decreases the stack size in the given slot by the given count. This one removes a stack from the given slot. This one converts all these slots to a non-null list, and this one sets it to a non-null list, and this one converts it to a string. So now if we go ahead and import that in here, we should see all those errors should clear up, and we should be left with the container error. Now in the block class, you do actually need to go ahead and cast furnace.getInventory to the item stack handler, and I also realized I made a stupid mistake of creating the item entity field before, and which obviously you can't do because it's the wrong scope. So you just need to go ahead and actually create that field in here, which isn't too much of an issue. I've just gone and imported it and fixed all the errors here. I forgot to put a .build, taken in null, which gave me a stupid little error, and all those little things. So this is actually going to be the end of episode 1 of the furnace tutorial, and in the next one I'll do both the container and the GUI class, hopefully in the same tutorial. So yeah, if you guys did enjoy this tutorial, please do be sure to smash your face into that like button and subscribe. If you really enjoyed it, please do be sure to share it. And yeah, I will see you guys in the next video. Goodbye.
Well, they said everybody not to panic, remain calm. Well, I don't know. There's 2 fucking rats fighting over food. You tell me how the world's looking right now. They were told to wait in line at the grocery store and go 2 at a time, and they said, fuck it. Let's throw down right here, right now. Big right jab there from the little rat on the left. The big rat on the right has the advantage right now. You can see him using his hands. He's trying to grapple him as he hops on top of the counter. He's got an angle now. Children watching at home, turn your heads. This is not Ratatouille. This is Ratatouille on crack, the X-rated version. Both trying to just get a piece of cheese at the market. And now it's turned into an all-out fucking warfare. The little rat is on top, and it looks like he slams him down on the ground. And he repeatedly slams him down.